we're going to look to solve for x. So this is maybe not as straightforward as the prior problems in terms of factoring, and you might be asking, why did we factor and now we're trying to solve for x, and what did those two things have to do with each other? Well, the only method you know right now to solve a problem like this is through the quadratic formula. So we know a is 1, b is 12, and c is 32. And so when you use the quadratic formula on that, minus b, let's review it again, plus and minus the square root of b squared minus 4 times a times c, all over 2 times a, which is, when I plug in, minus 12 plus and minus the square root of 12 squared is 144, minus 4 times a1 times c, 32, all over 2 times 1, which is negative 12 plus and minus 4 times 32 is 128. So square root of 144 minus 128 all over 2. Excuse me, which is the same. 144 minus 28 is 16. So minus 12 plus and minus the square root of 16 over 2. We know the square root of 16 is 4, so we get negative 12 plus and minus 4 over 2, which can be simplified to two answers. Negative 12 plus 4 is negative 8 over 2 is negative 4, or negative 8, because negative 12 minus 4 is negative 16 over 2 is negative 8. So these are my two solutions, and you can move on with your life. But what I'm telling you now is we're going to learn a slightly different way, and most people have told me an easier way than the quadratic formula in solving this equation. So let me move my quadratic variables over here and see if we can do it a different way. So we learned to factor, and again, we're looking for two numbers that multiply to 32 that add to 12. So looking at my multiples, and again, it's positive 12 and positive 32, so I'm looking at just the positives. If you're not sure of that, please look at the negatives as well. But I think you'll find as you look at the negatives, when I look at adding any of the negatives together, I get a negative, so that's not a useful combo. 36 and 32 and 1, 16 and 2, no 3, 4 and 8, no 5, no 6, no 7, and I'm back to 8. So the only combo that adds to 12, if any, is 4 and 8. So it should be x plus 4, x plus 8. And to solve this now, you might need to go back into your memory and remember that when you have two items being multiplied together to equal 0, either one has to be 0 or the other has to be 0. So the way you solve that is you set to equal to 0 for the purple, 0 for that scenario. And so if I subtract 4 from both sides, x negative 4 to make, and on the green, x plus 8 must be 0. Subtract 8 from both sides, x would be negative 8. So it's either negative 4 or negative 8. Now you notice it's exactly the result as we got. You factor it into two. Okay, so I'm going to use that mid in for try the next one. But if not, I'm going to continue. So I'm going to factor the left side into two binomials. Now I have x and x, because that's the way it's. And now I'm looking at factors of 77 that multiply to 7 of 77. 77. 1, 2 I don't think goes in. 3 does not go in, because when you add 7 and 7 you get 14, and I know 3 doesn't go into 14, so 3 does not go into 77. 4 does not go in. 5, 6, 7 I guess goes in. 7 times 11. And then notice 7 plus 11 is 18. So that's my combo. So plus 7 plus 11 equals 0. 0 product property. And I'll start to go a little faster on 0 product property, but this time we'll do it again. X plus 7 equals 0, or x plus 11 equals 0. What value of x makes those true? I subtract 7 from both sides on the first, and I get x equals negative 7, or subtract 11 from both sides, and I get x equals negative 11. So those are your two possible answers. And when you plug them back in, you'll find that the left side turns out to be 0. 0 equals 0 for both of the answers, and that's why these are your two possible solutions.